Part A. Prove that sine 2x minus tan x is identical to tan x cos 2x. So I'm going to start on the left-hand side. So sine 2x minus tan x. And I'm going to expand this double angle to get 2 sine x cos x. And whilst I'm at it, I'm going to rewrite the tan as sine over cos. Now I have two terms here, and I want to combine them together to get one term. So therefore, I need a common denominator. So I'm going to think of this first fraction as 2 sine x cos x over 1. And then I'm going to multiply top and bottom by cos. So I'll get 2 sine x cos x that I already had. And then when I multiply the denominator by cos x, that's also going to give me a cos squared on the numerator. So I'm just timesing top and bottom by cos x so that I've now got a common denominator. Which means that I can now write this as a single fraction. So on the numerator I'd have 2 sine x cos squared x minus sine x. Now I notice I've got a sine x in both of these terms, so I can factorise that out. At this stage, this is familiar to me. 2 cos squared x minus 1. I know that's the same thing as cos 2x. And at the same time, I've got a sine over cos, which I know is tan. So sine over cos is tan x. The 2 cos squared x minus 1 is cos 2x. And this is the right-hand side. This is what I needed to show. So that is part A done. Part B. Given that x can't equal 90 and x can't equal 270, solve between 0 and 360 this equation. So clearly this has got to have something to do with part A. So the first thing I'm doing is I'm comparing this to what I've just shown up here. Then I notice that this is the same thing as this. So therefore I could replace it with this. So that's how I'm going to start this off. So tan x cos 2x replaced will equal 3 tan x sine x. I am now going to make this equation equal to 0. So take 3 tan x sine x away from both sides. I can see I've now got a tan x in both of these terms, so I could factorise that tan x outside. So either tan x has to equal 0, or cos 2x minus 3 sine x equals 0. So let's first focus on that tan x equals 0, because that should be pretty easy to solve. If I do tan inverse, I get 0, and then just think about the tan graph for a moment. I know the tan graph looks like this. So I know it equals 0 at 0, at 180 and 360. I shouldn't include the 360 though. So I'm just going to give the 0 and the 180 as answers. So these are two possible answers. that I need to give. Let's now focus on the cos 2x minus 3 sin x part of this. Well, in order to solve this, I need to deal with this double angle. So let's expand that. Now, obviously, there's 3 different ways we can write cos 2x. I want the one that's going to match it up with the sin x. So cos 2x is the same as 1 minus 2 sine squared x. The cos double angle says that this is equal to this. Then I've got the minus 3 sine x equals 0. Now I have a quadratic, so let me write that in its usual form, so moving everything to the other side. And solving that quadratic, I find that sine x equals either minus 3 plus or minus root 17 over 4. If I do the minus, if I tried to do minus 3 minus root 17 over 4, that's not going to give me an answer because that's bigger than 1. If I tried, and you can check this on your calculator, if I tried to do sine inverse of minus 3 minus root 17 over 4, that's going to give me an answer that's less than minus 1, so I can't do sine inverse of that. There's no real solutions. So actually, I don't need to give that answer, it's only the other one. So x equals sine inverse of minus 3 plus root 17 over 4, which when I put that into my calculator, I get 16.3 degrees. Draw a quick sine graph to get the other solution. So my first solution was here at 16.3. There'll be another solution there. So if this is 16.3, then this is going to be 16.3. So to get my answer, I need to do 180, take away 16.3, which is 163.7. And therefore, these are all of my 4 answers to this equation.